Hello people, so my name is Josh. I was a computer science examiner for multiple exam boards, head of computer science in UK based schools, and now I run a tutoring business. These series of lessons is to give you all of the information that you need to know on particular units, and people seem to be enjoying much more the kind of longer style videos where we go over a whole unit in one. So I guess it kind of condenses it instead, so that you don't have to watch lots and lots of videos. So yeah, I can do that. The unit we're going to have a look at today is data representation. The data structures one, which is all stacks, queues, and things like that. Do go check that one out as well. So first of all, we're going to look at fixed point. So fixed point is essentially normal binary to denary conversions, but essentially it's just you've got a binary number in, you've got a decimal number in there. So if we go for, just put our numbers in there. So it says 4 bits for a whole number. So 8, 4, 2, 1. Now you can put fractions, or here it's got a decimal, so I'm going to put that. I'm going to put a decimal point there, and then we're going to put 0 0.5, 0 0.25. 0.125, and it does say 4 bits, even though we're not going to use it, but it would be 0.0625. Okay, now you just do your normal binary conversion, so it's going to be 1 for the 8 there, so that's 8, and then the decimal part is going to be 1 0 0 0, like that, and that's how you convert it in there. Okay, if you need to do subtractions, that's absolutely fine, but yeah, that's how you do that, people. This is the other way round. So what it's saying here is, please do make sure that you read the question, because it, as you can see, it does change. So it says 3 bits for the whole number. So I'm just going to put the decimal point in there, 3 bits for the whole number. So we've got 1, 2, and 4 on that one. So that's going to be 5. And then we've got 0. So then we've got 5 bits for the exponent there, which is going to be 0.5, 0.25, and then we've got 0.125 and then 0.625, so 0.0625. Okay, so then so in AQA you have a calculator, so just add them up. For everybody else, what I'd recommend doing is, don't be afraid from doing column addition with these, because I just see so many people make mistakes on these ones. So 0, 6, 2, 5, and then just put that in like this. 5, 2, 11, 1. So that's going to be 3. Just one there. Okay. And then we just write in the number after it. So it's going to be 3, 1, 2, 5. Perfect. Okay. So that's fixed point. You just go through. It's just putting the different binary the different decimal numbers above it, which is going to be the main thing which people get wrong. And as long as you do that, you're going to be absolutely fine on those. Okay. Now, the next one is 2's complement. So 2's complement is how you convert positive numbers into negative. So let's say they want us to convert minus 68 into a negative number. First thing that you're going to do is you're just going to convert it into an 8-bit number to start with, just positive. So write all your numbers down. So that's step 1. 8, 4, 2, 1. Okay, that's step 1. Then you just convert it into a normal binary number, so that's going to be 0, 0, 0, 1, 0. So that's 68 as a positive number, and then to a negative number is going to be we have to 2's complement it. This is my method. There are other ways of doing it, but I personally think this method is way better. You start from the right hand side and you go and find your first 1. Everything at it and before it stays the same. 1, 0, 0. Everything after it is flipped. 1, 1, 1, because they were 0, so now they become 1. And then that becomes a 0, that becomes a 1. So that's how we convert. That there is now negative 68. So just a review on that, what you do, convert it into a positive number to start with. Going from right to left, you find your first number. That is going to be, first number that is a 1. Everything at it and before it stays the same. Everything after it is flipped. Okay, binary addition. So with this, we're also going to have a little look at binary subtraction after this. So a couple of the rules that, just as a quick reminder, is obviously 0 plus 0 equals 0. Ones, which I see people make quite a lot of different mistakes in there, is so 1 plus 1 is where it gets a little bit weird. In obviously binary, that we can't have 2. So the way that we represent that is we do 0, carry the 1, which I'll show you what that means in a second. 1 plus 1 plus 1. It's 1, carry the 1. Again, I'll show you what that means in a second. Now, I don't think... I have seen it where sometimes when you have to add 3 numbers, but this example isn't actually going to show it. But you could get a situation where you could get 4 ones. And essentially what that has to do is it has to jump over 2 spaces, okay? And I'll show you what that means and how it all fits together. But so they're going to give you this, and they're going to say to you, can you add these 2 together? Okay, so it's always good practice to be able to do this, especially with later on that you have to do the binary floating point addition and subtraction, which if this isn't good, you're going to really struggle with that. So yeah, so with this one anyway, first of all, I'd probably go on the second lot here, because this is where I'm going to put my carries up at the top. So I wouldn't put like the first number there and the second number there. I'd literally just go in the middle and I'd put a number there and a number there, and then I can get all of my carries and everything all sorted. Okay, so that's step 1. And then I'm just gonna just convert the number. So 512 isn't going to go into that, so that's going to go there. 128. So I'll just do a quick bit of calculations there. Put a 6 there, so that's going to go, okay, 6, 4, 0, so we've got 46. It's going to be 1, take that away. That's going to leave us as 14. Okay, so, and then we're just going to go 0, and 14 is 8, 4, 2, 0. Little shortcut and 255. Because I know that for the 9th bit, that's 256, I know that it's 8 ones. So it's like if you got if you had to represent, for example, 63, it would be all of the ones here as well. So it's just a little shortcut, and it's just because I've been doing it a little while that I realized that. But so yeah, you guys gotta go 1 1 1 1 1 1 1 1. Let's have a look at how we do this. So we start from the right hand side and we go 0 plus 1. 0 plus 1 follows the same rules that you know, so that's going to be a 1. Now, when it gets a little bit confusing is when you've got to do 1 plus 1. So we have a little look at our rules up here. If it helps, just write them down next to it, and you do 1 plus 1 equals 0, carry the 1. 1 plus 1 plus 1 equals 1, carry the 1. That's that rule there. 1 plus 1 plus 1 equals 1, carry the 1. We've got 2 ones there. Confusing thing because people might not have seen it where you've got 3 numbers there, but it's just treat it as this rule up here. So it's going to be 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. 1 plus 1, so again treat that as this rule, so it's going to be 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. Then that's going to be there. And if it did want you to put, you know, all the rest of these bits in there, you just put zeros, but we're not going to do that. Okay, so that's how you do that. Now 3 numbers, so again we're just going to convert these. So we're going to put 19 0 0 0 1 0 0 1 1. So 3 16 is going to give us 19 there. 64 is 0. That was a bit of a weird 0. 0 64 0 0 0 0. And then we've got 2 0, so that's 66, and then 74 is going to be 0. Then we've got 10 to make up, so that's going to be 0 0 8 0 1 0. So as you do more of these, you will get better and better at that. I'm just going to move this up just slightly, just in case you can't see it very well. Okay, right, and then we go through these. So 1 plus 0 plus 0 is 1. 1 plus 1 plus 1 is 1, carry the 1. 1 plus 0 plus 0 is 1, 1, 1, 0. 1 plus 1 is 0, carry the 1. Then finally got that there, okay? And that's how you do that with 3 numbers. Now, I did say, so let's say for argument's sake that I had a carry, and I had that, and I had 4 ones there. In this situation, what do we do? So this 4 ones equals 4, okay? And it's not going to go into this column. It's actually going to put a carry on the one over the top of it. And that's quite a difficult one that people struggle with a little bit. So you just got to remember that it is a carry, but it's just going to jump over one, and it's going to go to that one. So that's probably the best way that I would explain that one, is that it's going to actually jump over the column on that one there. So that's if you get 4 ones. Binary subtraction. Now this is going to use a lot of the same rules that we've actually already done. So binary subtraction essentially works with the principle that if we add a negative number, we get the same result as if we take it away. So you don't have to learn any different rules. It just has a different, has one extra step in it where you have to twos complement it. So you can see this is the reason why I've decided to teach it in this particular order, is because what you're going to do is your binary addition, I'm sure, is excellent. And all you got to do is then you've just got to, at some stage, twos complement it, which is what we did before, the second number, and then you're all good. And I've got a bit of a weird example here as well to show you so that you can sort of see how that all fits together. So anyway, we're just going to convert 65 like this, which is going to be the positive number. So that's just going to be 0, 0, 0, 0, 1. And then 43. Now, I'm not going to write this one underneath it because that's where I need to put my negative number. So what I need to do is I'm going to put it as a positive number to start with, which is going to be 0, 1, okay? And then I've got 9 more to make up there for, 11 more. That would have been a bad one. 11 more to make up there. So that's going to be 0, 1, 0, 1, 1. So that's going to be 43 there, okay? Now, once I've got that, is I can twos complement it. So I use my rule, which is right to left, find your first one, which is here. Everything at it and before it stays the same. Everything after it is flipped. So 0, 1, 0, 1, 0, 1, 1. Right? We've now got that, and we just got to put it underneath this one now. So that's going to be negative 43. 1, 0, 1, 1. Okay, and then we just use the same rules that we did on this page for this one. So then we do 1 plus 1 equals 0, carry the 1. 1, 1, 0, 1, 0, 1, 1, 0, carry the 1, 0, carry the 1. And how this works, people, is this is actually, so as you can see, the number has become smaller if we forget about this one. And what's actually happened is something called an overflow error. So an overflow error is where we actually run out of memory, and this bit gets what's called truncated and just forgotten about. So it's kind of just one of those that somebody worked this rule out, and it actually means that binary addition and subtraction works perfectly in this case. So it will give us the correct number, and as you can see, the number has gotten smaller because there's more ones over here, which is, you know, is very interesting, you know, how that all kind of fits together, and it uses that idea of overflow to actually make it work. Just thought I'd show this weird example here and just sort of talk through it. I mean, it's relatively straightforward. Obviously, in maths, the rule is if you take away a negative number, it creates a double negative, which means you have to add it on. So just if they're being a little bit sneaky, just remember that all you're going to do is you're just going to add that 14 on there. So you just do you're just going to do 22 plus 14 because the double negative there means that you're going to get a positive number. But anyway, that's relatively straightforward. Now, going on to floating point. So there's 4 things that I need to show you about how to convert a floating point number into binary. Floating point is essentially has 4 different situations that can occur. A positive mantissa, positive exponent, a positive mantissa, negative exponent, negative mantissa, positive exponent, and negative mantissa, negative exponent. And what that means is floating point is essentially the idea in standard form in maths where you've got like 3.4 times 10 to the 4. Okay, it's just a more succinct way of representing the data. If you had a massive number with this, it's actually going to save you loads of space on a computer, because you can have, you know, infinitely large numbers on there. And if you can represent really, really big numbers and save a load of space, hardware is only has its limitations. That's going to be great. So that's what the idea of floating point is actually doing, is it's trying to save a space for representing really, really big or really, really small numbers. So the method on this, and I might run out of space on this, but we'll give it a go, is the idea is the exponent, this part tells us where we're going to move the decimal point to, and this one over here is going to tell, and this one is actually the number. Now, for positive mantisses, they will always be 0, 1. Negative mantisses will always be 1, 0. I have seen questions with the exponent where don't necessarily, so 0, it will always be 0, 1 for a positive exponent, but it can actually be 1, 1 as well on some of the exam questions that I've seen. So just look out for that. If there's a 1 at the front of the exponent, you have got to do some 2's complementing. I will show you how that all works. So how does this work then? So the exponent, so step 1 is convert the exponent. So we're just going to put 1, 2, 4. I could put that there, but it's irrelevant. 6. So that tells us that we're actually going to be moving the decimal point 6 places. Okay, the number's got to get bigger. So we're going to go 1, 2, 3, 4, 5, 6. Put a little decimal point there, and then I'm going to redraw my number just so that I can remember where everything is. So 0, 1, 0, 1, 1, 1. Then I just put the numbers over the top of it. So the decimal points here, so that's going to be 1, 2, 4, 8, 16, 32. And that's going to be 0.5. So 32 plus 16 is 48. 48 plus the 8 is 56. And then plus the 2 is 58. And then we've got 0.5 there. So let's just add that on there. So that number there is going to be 56.5. 58.5. I do apologize. So yeah, 58.5 there. Okay, so that's how you do floating point mantissa. Just going through those steps again. Exponent tells you how many times you're going to move the decimal point. The mantissa tells you the number on this. So the actual what the number is. So you work out the exponent, you move it, and then what you do is then you and then just convert the number in normal fixed point binary, which we did before. So as you can see why I've taught it in this particular order, and that gave us 58.6 in there. So that gives us all of that. Now I'm actually just going to take this out because I need more space for this one. So floating point, so positive mantis and negative exponent. You can see here I've got a negative exponent because I've got a 1 at the front. So step 1 that I need to do is I actually need to 2's complement this. So find my first 1, everything at it, and before it stays the same, everything after it is flipped. 0, 0, 0. That then gives me a negative 1. Okay, with the negative 1, what that's going to tell me is that I have actually got to make this number smaller. Okay, so before I can move the decimal point, I have to move it to the left, but to do that I need to actually put an extra 0 in there. What I'm going to do is I'm going to move that over to here, and I'm going to do 0.01. Yeah, so you put in the number of zeros for the exponent. So if I had a negative 3, I would put 3 zeros there, and so on. Negative 4, I put 4 zeros, and then I just redraw my number. So 0 decimal point 0 1 1 1. Like that. I could put in the rest of the zeros, but they're not going to have any bearing over my actual answer. And then just write the numbers in there. So that's going to be 0.5. I'm going to show you how to do it with a fraction, actually, because I personally find it easier with the fractions. But you know, if you find the decimals easier, you know, use the decimals. There's no problem in doing that. It's just personal preference, and it's still correct either way. So put the fractions in like that. So half, quarter, eighth, 16th. So to add that, in here, you know, so what we're going to do is we're going to times this by 2, because to add fractions together, the denominators both have to be the same. So then that gives me 2 over 8 plus 1 over 8, which that's going to give me 3 over 8. Okay, and then final thing that we've got to do is we're going to times that by 2. Times that by 2, which that's then going to give us for the 16 on the end there, so that's going to give us 6 over 16. Then we're going to add the 1 over 16, which then that gives us 7 over 16. Okay, so that's our answer there. So personally for me, I find it easier to use fractions, but that's it's personal preference. If you prefer using decimals, use the decimals. That's fine. So okay, so in those ones there, what we're going to do now is we're going to go for the negative mantissa, positive exponent. So I'll move this one up a little bit, and what we do is we go for the. So what we do is we can see that we've got a negative mantissa, which is where this one here is. It's got a 1 0 there. So what we do is it doesn't really matter which order that you do this in, but 2's complement the exponent, which is 4. That tells us that we have to move it 4 places to the right. The number is going to get larger, and then what we then need to do is 2's complement this before we start moving the exponent. So that's the decimal point, which is where I see a lot of people go wrong on this one. So that's going to be 1 0 0 0. So right to left, find your first one. Everything at it and before it stays the same. Everything after it's flipped. 1 1 1 0. And then what we're going to do is we're going to move to the right. So we're going to go 1 2 3 4. Then so the decimal point is going to go here, which then that's going to go 0 1 1 1. And then we have got a 1 right at the end there, so we just do need to take into account about that. So it's like that. Okay. So that is going to be 1 2 4 8. So that's going to be 14. And again, you can just put the fraction here. So that's going to be half, a quarter, and an eighth. So 14 and an eighth. Now, mistake where everybody always makes on this one, they forget to put the minus in there. If you forget to put the minus, you do lose a mark on this one. So be super, super careful, people. If it's a negative mantissa, it's a negative number. That's what it's telling you. So just be careful on that one there. Okay. Final one is negative negative. So negative negative is where you've got a negative mantissa and a negative exponent. So what this one is where you have to 2's complement both of them. So what we're going to do is we're going to go to here, 0 1, everything at it and before it stays the same. Everything after it is flipped. So so here is going to be 0 and 0, and then that's going to give us negative 2. Now what we would do before we added so we would 2's complement this first, and then we're going to add the zeros in. So I go right to left, so it goes to this one, everything at it and before it stays the same, 0 0 1, and then everything after it's flipped, 1 1 0, decimal point in there. Now this is telling us that this is going to get so we need to move it 2 places. So we're going to go 0 0, and then we're going to go 1 2, and then that redraw our number. So it's going to be 0 0, and then we're going to get a very, very small number on this one. So that is going to be so just double check I did that correctly, because that's 0. Yeah, no, it is. So that's going to be 1 2. Yep. So here, now what we have to do, I'm going to use my fraction. So half, quarter, eighth, 16th, 32. Okay. So they're adding so times that by 2, that's going to give me 2 for 16 plus 1 over 16, which that then gives me 3 over 16. 3 over 16. And then I need to times that by 2, so then that's going to give me 6 over 32, so I can add it to the 1 over 32, which is going to give me that. Now, mistake which everyone makes, forgets to put the minus in. So negative mantissa, it's just a very, very small negative number, which is minus 7 over 32. Couple of little, that's in a bit of a weird format. Just a couple of little sort of 1 2 markers that they seem to like to put in. That's a bit easier to read. There you go. They like to ask. So for this question up here, it's what happens when you increase the precision of a number, and what happens when you increase the exponent of a number. So if you increase the mantissa, the number of bits, or decrease them, vice versa, increase the exponent, decrease the exponent, what happens to the number? The mantissa is where so what happens is you increase the precision. It just means that the number can be more precise, and like you can be more specific with the number that you're trying to represent. So that the key word that they're looking for there is that the precision is increased, and the inverse is also true. If you decrease it, then the precision decreases. The exponent is there's a greater number of numbers that you can actually represent if you increase it, and then the inverse is also true. With this, overflow can also happen is the number is too large to be represented with the number of bits that you have available. Underflow is too small to be represented with the number of bits available. Is probably, I'm actually going to change that with number of bits available. So I'm just going to slightly change that one there for you, because I personally think that's a bit of a better sentence there. There you go. Number of bits. Number of bits available. So there you go. There you go. Sorted. Last bit, people. Last bit. Oh, actually, I think we've still got a little bit more, actually. So, well, we'll keep going. Okay, so normalization. Normalization is the idea of essentially if we have a number here is 0.34, okay, times 10 to the 3. What happens here is this number isn't actually normalized until it becomes this. So because I've moved the decimal point to here, I actually need to make this one smaller, which is that's going to be times 10 to the 2, okay? And it's the same principle as in normalization. Positive numbers have to be 0.1, and this one over here needs to be 1.0 because there's ones at the front. If it's positive, it needs to be that. If it's negative, it needs to be this. So in this case, what we're going to do is we need to see how many times we need to move the decimal point. So remember, positive needs to be 0, 1. So I'm going to go find my first 0, 1, 1, 2. So then that's going to be 0, decimal point, 1, 0, 1, 1, 0. Add in the zeros that you need there. Now I've moved it 2 places, so I need to subtract 2 away from my exponent because I've made the mantissa bigger. So I need to make I need to counteract that with the exponent and make that smaller. So that's 3. So I subtract 2 from that. So then that is going to be 0, 0, 1. So move the decimal point. Then once you've moved it that number of times, what you then do is then you subtract it from the number, the exponent. For this one, we have to look for 1, 0. So the first time we've got 1, 0, which is there. So again, same principle. 1, 2, 3. Okay, that's great. And then we're going to go 1, 1, 0, 0, 0, 0. So just add in zeros for the rest of it. And then we had to move that 1, 2, 3. So we move that 3 times. So then that's going to be there. Take away 3. So it's going to be 0. That's 6. So now this will equals 3. So again, just make sure, because it's a negative number, it needs to be 1, 0. And then that's going to become 0, 0, 1, 1. Tying this all together, we have to be able to convert between denary numbers and floating point as well, so go in the other direction. So first things first, what you need to do is you just need to convert it into a normal 8-bit number. Now we have got a decimal number in here, so I'm going to put 64 here, and then I'm going to do 32, 16, 8, 4, 2, 1, and then 0.5. Okay, and then I just convert 45 like so. So I'm going to go 0, 1. I've got 13 to make up there, so that's going to be 0, 1, and then it's going to be 1, 0, 1. So that's 45, and then the 0.5 is going to just be there. Decimal point is here. So that's the first stage, is just convert it into fixed point binary. The last stage is where we are actually going to move it. We have to essentially, normalize it like we were doing on the other ones, but this tells us what the exponent is going to be. So I need to move it so that it's on where it's 0, 1, and it's got to be the furthest 0, 1 on the left hand side. So we're going to go 1, 2, 3, 4, 5, 6. So we move that 6 times. Just put a little decimal point in there to help you remember. 1, 0, 1, 1, 6 times, and then that our exponent is going to be 0, 1, 1, 0, because 1, 2, 4. Yeah, so that's on there. So 8 bits, 1, 2, 3, 4, 5, 6, 7, 8 for our mantissa, and 4 bits for an exponent. 1, 2, 3, 4. Okay, and that's the answer there. Okay, so that's how we do that. Converting a negative number into floating point. So we just have to go through a couple of stages on this one. It's just an extra step. Once you've converted it into fixed point, you just need to convert it into, you just need to 2's complement it, and then just make sure that the decimal point goes between the 1 and the 0 there. So the on this one here, we're going to go for, we'll go for 64, 64, 32, 16, 8, 4, 2, 1, and then we're going to do 0.5. Okay, so then we're just going to put our numbers in like so. So we're going to go for 14, which is going to be 0, 0, 0, 1, 1, 1, 0, and then we'll put in a 1 there. Okay, so with this one here, what I'm actually going to suggest is, instead of us having a load of leading, actually no, that is correct. So yeah, we'll go with that. And then what we need to do from this point is we're going to actually 2's complement it, because it's a negative number. So what I'm going to do is I'm going to go right to left, find my first 1 and everything at it before it stays the same. Everything after it is flipped. So 1, 0, 0, 0, 1, 1, 1. Once we've got that, then the big thing to remember on converting a negative number is that it needs to go in between the 1 and the 0. So on the left hand side. So it's going to be this position here. So I'm going to move it. So I'm going to go 1, 2, 3, 4. I can actually forget about these ones, so I'm going to put 1, 0. So I'm just going to go from here, 0, 0, 1, 1. And if it wants it as an 8-bit number, I need to so that's then going to be 2 more bits there. And then I moved it 1, 2, 3, 4. So the exponent needs to be 4. So that's going to be like that. So that's 4 because 1, 2, 4. And then this one up here is then going to be a negative. That's then converted into a negative number and ready to be converted back at some point. So on this one, brilliant. Okay, so the last little part of this is being able to add 2 binary numbers, floating point binary numbers together. I did write down some little instructions as well, just to help you out as well. There's kind of 5 stages, 6 on when we've got to subtract them, because you've got to add them and to be able to subtract them. Now, with the last little part on here, if you imagine with like 3.4 times 10 to the 3, and then I had to add like 2.7 times 10 to the 5, the way that the method in which I would do this is I would convert it first and then add them, and then convert them back into standard form. I can't just like start adding them, because it's not going to work. So yeah, it's the same principle in this. So what we do is we go for, 2's complement them to start with, and then you're just going to use not 2's complement them, sorry. You convert them using the floating point method, so you move the decimal point, then you can just add them. You don't actually even need to convert them into denary, and then you add them together, and then you can convert them, normalize them again, and then it's all good. I'll show you what I mean. So this one here is, so that's going to be 2. So what I'm going to do is I'm going to move this 2 places to the right, so 1, 2. Now, very, very important that we have to match them up so that that all of the values are in the same place, and I'll show you what I mean by that. So what we're going to do is we're going to go 1, 1, 0, 0, 1. I could put in the other numbers, and I may have to pad it out if the numbers are are a little bit different from each other. That's absolutely fine, and I'll show you how to do that in a second. This one here is 4, so I need to move this 4 places, so that's going to be 1, 2, 3, 4. Decimal point is going to go there. Then in this case, I have to, so I put that under there like that. And then can you see on this one here, I'd go for like 0, like that 0 goes under this one. Even though that they're not in the same place, it's because the decimal point is there and the decimal point is there. So I have to match it up. 1, 1. Put some zeros just to pad it out up at the top. And then also we need to make sure that we get the 1s here as well, people. So, and then put a 0 there just to pad that one out. Add them together. I'm just going to move this up slightly just so in case some people can't see very well. So I'm going to move that up. So then what I'm going to do is I'm just going to add it up. So 1, 1, 1, 1, 1, 1, 1. Now it is positive, so I'm going to add in another 0 there. Okay, so the principle of this now is, so I've added them up, everything's lovely. And all I'm going to do now is I'm just going to move the decimal point now. So that's going to go 1, 2, 3, 4. Remember that you've moved it 4 times. And then the exponent now is going to be 4. Just make sure I did the correct number of 1s there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And that's how you do it there. So I'll just go through the steps because there are a lot of steps with this one. You exponent, so move it, move them, then write them in their respective position. So once you've converted the exponent and you've done that, then you just add them all up, and you then make sure that you normalize it so it's 0, 1 or 1, 0 if it becomes a negative number. And yes, so that's going to that gives us that. And then once you've moved it, you just count the number of times that you moved it. It was 4 times, and that gives us 0, 1, 0, 0. Okay, final one to do, final one. So with this one here, what we need to do is we just need to go for subtracting a negative number. Sorry, not subtracting a negative number, just subtracting a number. And with this one, we're actually going to get a negative number as an answer because I believe the number underneath is larger. And you kind of just get better at realizing that this is happening. And a little check that you can do if you've got time in the exam, if you're a person that kind of goes right up to the end in exams, I'd maybe just suggest, if you go right up into the exams, just go through the steps, you'll be fine. But if you have got time to check, you can just convert them into their equivalents, and you will actually see that in this one, this number is larger than this one. And the exponent also can sometimes give it away a little bit, because that's actually going to be, well, it's 3 and that's 2, so it's the likelihood is that this one's actually going to be larger. So the answer should be negative. Anyway, so let's have a look at how we do this. So step 1 of what we're going to do is we are going to just do our normal thing, which is convert these. So that's 2 and 3. Okay, now we have to add in an extra step. So first, this one here, we're not doing anything different with this one. So the decimal point is going to go there, and I draw my number. 0, 0, 1, like this. Perfect. So that gives us that. Oh, that gives us that. Now, once we've got that in there, all I have to do now is I'll just put an extra 0 there as well. With this one here, I actually need to 2's complement this one because we're going to use that principle I was talking to you about when we were doing binary subtraction, that if we change it to, if we add a negative number, it has the same effect as just taking it away. So we don't have to learn any different rules. We can just go with that. And this one here is I need to move this. So what I need to do is I need to actually 2's complement this one because we're going to change it to a negative and then add it on. So 0, 0, everything at it and before it stays the same. Everything after it's flipped. 0, 1, 0, 1. Okay, decimal point is there. We know that this is 3, so then we move the decimal point. So 1, 2, 3. Okay, remember that we've put it there. Okay, so that the 1 is the other side of the decimal point. We put that there, and then that's going to be 0, 1, 0, and I'm going to put a little 1 there. Okay, now put in some zeros there, people. That's going to essentially work in that particular way. Then we just add them up. So we're going to go 1, 0, 1, 1, 0, 1, 1, and 1 on that one there. So the decimal point is going to go here. In this particular case, what I'm actually going to do is remember me saying to you that this number is larger. So we're actually going to get a negative number there. So a mistake that some people might make is they might put a 0 there and go for that and be like, oh, it's positive. We're actually going to go here. Okay. So it feels a little bit weird because we're like, there's a 1 there. Like, are we not getting rid of something? It's a negative number. That's actually what we want to happen. So in this case, we're going to go for the 1 and the 0. So what I'm going to do is I'm going to go 1, 2. Forget about this 1 up here, and then I redraw my number depending on where how many bits it wants me to do. So I moved that 2 places. So 1, 2, 3, 4, 5, 6. So I'll put in a couple of zeros, just pretend it was 8 bits that it was looking for. The decimal point is here. I moved it 2 places, and then the exponent is going to be 2. Okay, people. I think that was the longest video I've ever done. I hope it was useful, and I really wish you the best in your exams, because they're very hard, and I just hope that it helps you out. Take care, people. Thank you very much.